everyone, Miss Helens here, and I'm going to go over our next experiment, which is going to be Newton's paper airplane. So yesterday you worked on filling in Newton's first and second law. Today we're going to actually take a look at a very similar experiment to the paper airplane, but it's actually a glider. So what you see in front of me here is the glider. So basically this entire demonstration is to show you what happens when an object's motion changes based on the sum of its forces. So I'm going to be showing you some different ways that this glider can move based upon its different amount of forces. So over here, you're going to look at the demo questions first. Number one, what type of forces must the glider have in order for it to remain still? So as you can see, the glider right now is still. It's not currently moving, it's just hanging out there. Think about what type of force. Think about Newton's first law. An object at rest stays at rest, an object in motion stays in motion at a constant velocity unless acted upon by an unbalanced force. So if that's the case, what kind of force is acting upon this right now? It's kind of just sitting at rest. So what kind of forces would act upon it? And then for number two, you're going to write down what type of forces must the glider have in order for it to change its movement. Okay, again, think back to Newton's first law. What kind of forces will it need in order for it to start moving? So pause this video now, answer questions 1 and 2. All right, at this point, now we're going to take a look at this box here. Basically, this box shows us what types of forces are acting on the glider at any one given time. Obviously, we have the force of gravity pulling it down, but we also have the force of tension. It's kind of hard for you to see in this video, but there's some fishing line that is keeping the glider up. So the fishing line is the force of tension that's pulling it upwards. We do have the force of friction between the straw and the fishing line, but we also have the force of thrust from the rubber band and the propeller. So our goal is to see what happens when we let this glider go, when we give it more thrust than there is friction. So we're going to kind of see how this all plays together. So if you take a look at question 3, this is what we're going to answer in just a second. It's asking, when the glider had more thrust, how did it move and in what direction? So we're going to increase the amount of thrust on this glider right now. And the way we're going to do that is by spinning the propeller, which has a rubber band attached to it. So by spinning the propeller, we're going to give the rubber band some potential energy, which when we release it, will transition to kinetic energy and it will move, hopefully. So I'm going to spin it roughly about, let's say, 10 times to start with. We'll see how it moves, and then I'll increase the thrust by turning it more. So if I give it 10 spins, all right, so 10 spins. Okay, goes about a quarter of the way across the line. So if we increase the thrust, the forwards force, hopefully it will go further, right? How would we do that? Probably by increasing the number of spins. So I did 10 spins. Now I'm going to do 30, and we'll see how far that can go. All right. Woo! Made it all the way across. So when we increase the force of thrust, we saw what happened to the glider as it moved along the wire. Okay, what you're going to do in number 3 is, when the glider had more thrust, how did it move? And why did it move in that direction? You can answer that now. All right, guys, so we are back for part 2. I now have a lovely audience in my room, so now I'm wearing my mask. Yes, you can clap, that's okay, that's fine. Oh, thank you, thank you. Okay, so now we answered number 3. We're going to take a look at number 4, which is asking, when the glider had more friction, how did it move and why did it move in that direction? So in order to change the friction, I'm going to change the type of wire that we're using. So goodbye fishing line. And now we're going to be using yarn. So this is just the yarn that we use from the Egg Drop Project. So I'll stick through the So hopefully this will add more friction because the yarn is made up of little teeny bits of cloth kind of together to make a long string. So even though it's soft, it's actually got more friction because of those little cloth pieces will kind of slow the straw down as it moves. So now we're going to see how it moves with more friction. Remember last time we spun this propeller, 10 spins got it about a quarter of the way and 30 spins got it to the end of the track. So now we're going to try with 10 spins. All right. And it went nowhere. So let's try 30, see how that fares. All right, 30 spins. Okay, we got less than a quarter, probably like, I don't know, maybe an eighth or a tenth of the way across the line. So clearly adding more friction affected the way that the glider moved. What we're going to do is take a look at number 4 now, and you're going to answer when the glider had more friction, how did it move, and why did it move in that direction? Again, you want to be thinking of this diagram and how the force of friction affected the force of thrust. Okay, think about net force and balance and unbalance. That's it for today. You're just going to be answering these two, and when you come back into school, we're going to be working on the rest of the package. So don't move on past this point. I'll see you guys when you get back to school.